In this video, we're going to work example problems on partial fraction decomposition. So let's get started. Okay, so the first step is you check the rational function to see if the order of the numerator is greater than or equal to the order of the denominator. In this case, it's not. We can see the order of the denominator is 2, the order of the numerator is 1. If it was the case that the order of the numerator was greater than or equal to the order of the denominator, we have to start by doing polynomial long division. But since the order of the numerator is 1 here and the order of the denominator is 2, then we can go and proceed forward with the partial fraction decomposition process. Okay. The next step is to factor the denominator. Remember, all polynomials can be, no matter what the polynomial, can be factored to a product of linear and quadratic factors. The strictly linear and quadratic factors. And so that's the next step, is to factor the denominator. Here the denominator is already factored. We're starting with easier problems. Okay, so now once the denominator is factored, the next step is to write out the form of the decomposition. What that means is we're going to write out all of the, so we're writing out the form, we're going to write out the separate terms that we're going to be decomposing this into. And we do this by looking at the denominator of the original function. Strictly the denominator. We're not looking at the numerator at all. Strictly the denominator. And what happens is that each factor of the denominator, each factor in the denominator is going to be associated with one or more of the form pieces. Okay? So you go to each factor and you go factor at a time. You come to each factor and you write out one or more form pieces that are going to be associated with that factor. Okay, so again, here we've got two linear factors. The linear factor has the form ax plus b. Okay, and so with linear factors, and not only do we have just two linear factors, but both are to the first power. And so when you have a linear factor to the first power, so if we look here first, here's a linear factor to the first power, you just put, its form is you just put the linear factor in the denominator, and then in the numerator is a single constant. And then you're done with it. Because this is to the first power, we're done with this factor. We come to the next factor. This is another linear factor to the first power. Do the exact same thing. Put the linear factor in the denominator, and then in the numerator put a constant, a different constant. That, these are different constants. And now we're done with this factor, and that's it. We've written the form of the decomposition. Okay, and so now the next step is we just need to solve for what A and B are. Once we have A and B, we're done. We've performed the decomposition. So how do you do this? Well, the first step is you multiply the entire equation by the least common denominator here in order to clear the fractions. Okay, the least common denominator is x plus 4 times 2x minus 3. Okay, so we're multiplying both sides by this same value. So we've got minus x minus 37, right, is equal to a times 2x minus 3 plus b times x plus 4. Okay, now to solve for A and B, there's two methods you can use. One method is, so we distribute that, we expand all this out, we bring all the x terms together, and then we bring all the constant terms together, and we have those in two groups, and then we set the coefficient on the x terms equal to, it would be minus 1 in this case, and set all of the constant terms equal to minus 37. That's one way. Another way is because this is an identity, meaning we know these equations are equal. Like, we're not solving this. We've defined it to where the A, whatever the A and the B are, make this equation equal. Make these two sides equal. You know, sometimes you're solving an equation and maybe it's not equal. Well, these are equal because that's the definition of, that's how we set it up. So what that means is that for all values of x, this equality is true. So we can just pick a value of x, and as long as it leaves, you know, some you know, an a or a b there, then, you know, and there's something we can solve with it, then we can solve it. So we can pick x's that perhaps would get rid of like the b, or get rid of the a, and just leave one of the other, and we can then solve, because once we input the x's are gone, right? And then by inputting that x, like the b gets removed. If we said x is equal to -4, the b disappears, and we're left with just the a and just numbers. So we can solve for the a. And so sometimes that method works and sometimes it doesn't work. I think what I've found is that if it's a simple partial fraction decomposition, then going that route is pretty easy. If it's less simple, then doing the method where you, like, let me do that to show you that method, right? The method where you group the x terms together, or the x squared terms or whatever together, and then let me show you that here. So, all right, we've got minus x minus 37 is equal to 2ax minus 3a plus bx plus 4b. So now we bring all of the x terms together, and we bring all of the constant terms together, because a and b are constants, right? And then we factor out an x here. And then here we've got, okay, so now we can set 2a plus b equal to what's the coefficient in front of the x, which is -1, and then we can set 4b minus 3a equal to -37. And if there was like an x squared, then we do the same thing. And so then we'll have to solve two equations and two unknowns, but which is kind of cumbersome. And you can see if we just said x is equal to -4, then we could solve for a real quick. And to me, that's quicker in this case. But for other equations, you have to go this route. Or maybe you can, and sometimes it's easy, like what you can do is you can use the method where you input an x to get, you know, to solve for one of the constants, or maybe to get a simple equation for one of the constants, and then you go the route, the grouping route, and kind of those two methods together can make it easier to solve. So, all right, but okay, we've got 2a plus b is equal to -1, and then we've got 4b minus, or no, okay, minus 3a plus 4b is equal to -37. So let's multiply this top equation by 4. So we've got 8a plus 4b is equal to -4. Okay, so we've got 11a, and then the 4b subtract out is equal to -4 plus 37 is 33. So a is equal to 3. 33 divided by 11 is 3. Okay, so if we come to this equation, 2 times 3 is 6, plus b is equal to -1. So b is equal to -7. Okay, and so there you go. We've got this rational function is equal to x plus 4, and then 3, and then minus. That's it. Okay, step 1, check to see is the order of the numerator less than or equal to the order of the denominator. Remember, we're strictly with partial fraction decomposition. We're strictly dealing with rational functions. So you're going to have a rational function, or a rational expression is a ratio of polynomials. If you don't have a ratio of polynomials, then there's no partial fraction decomposition. Okay, so first step, you check the order of the polynomial in the numerator. Is it less than or equal to the order of the polynomial in the denominator? In this case, it is. Okay, so next step is factor the denominator. And you can always factor the denominator. You can factor any polynomial into it's a product of strictly linear and quadratic factors. So that's what you need to do. So you're going to need to factor the denominator into a product of strictly linear and quadratic coefficients, or linear and quadratic factors. Okay, so we can take out an x, and we've got and there we go. We have linear and quadratic factors. This is x minus 0. So a linear factor is ax plus b. This is a linear factor with a is equal to 1 and b is equal to 0. This is a linear factor with a is equal to 1 and b is equal to minus 2. All right, next we write out the form of the decomposition. And so you come to each factor. Here we've got two linear factors. And so linear factor that are both raised to the first power. So a linear factor raised to the first power is just you put the factor in the denominator, and then the numerator is a constant. That's it. Done with x. Now x minus 2, we put x minus 2 in the denominator and put a constant in the numerator. That's it. That's the form of the decomposition. Now we clear the fractions. We need to solve for a and b. We clear the fractions, multiply by the least common denominator. So we've got 8x minus 10 is equal to a times x minus 2 plus b x. Okay, so let's do this method. We'll say, what if x is equal to, let's come here. What if x is equal to 2? Okay, in that case, 8 times 2 is 16. A goes away. Okay, so we've got 2b is equal to 6. B is equal to 3. Okay, now what if x is equal to 0? Then we've got minus 10 is equal to 0 here, and then 0, so minus 2a. A is equal to 5. See, that can be quicker. In some cases, it's quicker to do it this way. In some cases, it's not. Okay. So this is equal to 5 over x plus, and then there you go. That's the decomposition. Okay, step 1 is the order of the numerator less than or equal to the order of the denominator. Yes, it is. Okay, next step, factor the denominator. And we went through in the start of this playlist, we went through factoring in full. So if you need to go back to the factoring section or the factoring example problems, do that. All right. So here we've got okay, so 3, 2, W plus 3 minus 2. W squared minus 2W plus 3W minus 6. There we go. Okay, now let's write out the form. We've got two linear factors, both raised to the first power, so that's easy. W plus 3 like that. Okay, multiply by the least common denominator. Okay, so we've got 6W minus 7 is equal to A plus okay, so now what if we make W equal to 2, then we've got 12 minus 7 is equal to 5b. So 5b is equal to 5b is equal to 1. Now what if we make w equal minus 3? 6 times minus 3 is minus 18. So minus 3 minus 2 is minus 5. Minus 18 minus 7 is minus 25. So a is equal to 5. So we had a over w plus 3. Okay. All right. So a over w plus 3 plus b over w minus 2. There we go. Okay, step 1, we check, is the order of the numerator less than or equal to the order of the denominator? It is in this case. Okay, next step, we factor the denominator. We don't worry about the numerator. I mean, you can factor the numerator if you feel like you can simplify the equation or the function, but in general, we're just factoring the denominator. Okay, so we went through factoring in full detail at the beginning of the algebra playlist, at the beginning of this playlist. So take a look at that if you need. But okay, so we take out an x. All right. Okay, can we, here's a quadratic factor, which, we could just leave this as it is if we can't factor this any further. But if you can factor it further, then go ahead and do that. And this looks like a perfect square trinomial. This looks like x plus 5 squared. X squared plus 5x plus 5x plus 25. Yeah, it is. So okay. So we've got x squared plus 26x plus 100, and then x. Okay, so we factored the denominator. Now we need to write out the form of the decomposition. Here we've got two linear factors, an x plus 0 and an x plus 5, but one of the linear factors is squared. All right, but so we'll start with this linear factor. This is x plus 0 to the first power, and so we just put a constant over that linear factor. All right, now when we have a linear factor to a power other than 1, it's going to be, after you factored, it's going to be, the factors are going to be to integer powers, positive integer powers. And so if you have a linear factor to a power other than 1, then what you do is, so you put, we're going to say, okay, x plus 5, and then that's under b, and then we're going to do plus x plus 5 squared, like that. So this part of the decomposition is associated with this, and then this part is associated with this. And if this was cubed, we would do b over x plus 5 plus c over x plus 5 squared plus d over x plus 5 cubed. Okay, but that's it, though. There's the decomposition. So now multiply by, we just need to solve for a, b, and c. So multiply by the least common denominator. We've got x times x plus 5 squared. So x squared plus 26x plus 100 is equal to a times x plus 5 squared plus bx times x plus 5 plus cx. Okay, and so again, you can go either of those either of those routes, grouping the terms together or just choosing an x, or you might have to do both. So like, in other words, I guess to me, what I would do, my suggestion would be, in general, start out by, like we can see here, if I say x is equal to -5, then I can solve for c. So let's just go ahead and do that, right? And then do I would say start with this method first, get all the information you can, and then if you can't go any further, then go to grouping and and then you'll have the grouping combined with the information you already have, you can solve it. So when x is equal to -5, then you've got 25 plus, so 26 times -5, okay, minus 130 plus 100 is equal to, and then these go away, and you're left with minus 5c. Okay, so 25 minus 130 plus 100 is minus 5. Minus 5 is equal to minus 5c. So c is equal to 1. Now we can also say, what about when x is equal to 0? So we've got, we'll have, this goes away, this goes away. We've got 5 squared, so 25a is equal to 100. So a is equal to 4. Okay, and then now we can say that, okay, like x is equal to 1. So we've got 1 plus 26 plus 100 is equal to 4 plus 5 is 9. 9 squared is 80. Or no. 1. No, okay. 1 plus 5 is 6. 6 squared is 36. 36 times 4 is 144. Okay. Plus, when x is equal to 1, you have 6. So it'd be 6b. And then here, plus c is 1, x is 1, so like that. So 126 plus 1, all right, we've got 145 plus 6b is equal to 127. 6b is equal to 127 minus 145 minus 18. B is equal to minus 3. Okay, so we've got C is 1. B is minus 3. So we'll do... and A is 4. And that's the decomposition. Okay, first step is the order of the numerator less than the order of the denominator. It is. All right, next step, factor the denominator. Don't worry about the numerator. Okay, so we can take out a 2x. And we've got x squared plus 9. Okay. Okay, so that's fully factored. We can't do anything more with the x squared plus 9. If it was x squared minus 9, we could. And so we've got, it's fully factored because we can't factor it any further, simplify it any further, and we've got strictly a product of linear and quadratic factors. So the linear factor, we've got ax plus b. A is equal to 2. Here, b is equal to, for this 2x, a is equal to 2, b is equal to 0. Okay, the quadratic factor is ax squared plus bx plus c. A is equal to 1. C is equal to 9, B is equal to 0. See? All right, so we've got the denominator factored. The next step is to write out the form of the decomposition. So we go factor by factor. Each factor is going to have its associated form of the decomposition with one or more terms. All right, so we've got this linear factor to the first power, so that's it. Okay, now a quadratic factor is the same exact concept. When it comes to the powers on the quadratic factors, it's the same exact concept as the linear factors, where you just you have separate ones for each power of the same form. But however, the difference is that, so this is to the first power, x squared plus 9 to the first power. So what we do is, just like the linear factor, we just put the quadratic factor in the denominator, but in the numerator, we put constant times x plus another constant. And you make sure all these constants are different constants. Now this is just to the first power, so we're done. That's the decomposition, the form of the decomposition. So now we just need to solve for a and b. Multiply by the least common denominator. So we've got okay. All right, so here, just looking at this, it seems like it would just be easier to go ahead and do the method where we group the x squareds and the x's and the constants together. If we choose x is equal to 0, well, actually, okay, no, if we said x is equal to 0, we could get the a here, so let's do that. Yeah, so 9a is equal to 45. A is equal to 5. Okay, so now we can 13x squared plus 2x. All right, so we've got 5x squared plus 45 plus 2bx squared plus 2cx. Okay, so we've got 5x squared plus 2bx squared plus 2cx plus 45. Okay. So we've got 5 plus 2bx squared plus 2cx and then plus 45. 45 is equal to 45. So, I mean, those cancel out. But we've got, so 2c is equal to 2. You see? 2c is equal to 2. So c is equal to 1. All right? And we've got 5 plus 2b is equal to 13. 2b is equal to 13, 12, 11, 10, 8. B is equal to 4. And there you go. So the decomposition is A is equal to 5. Okay. And then we've got 4x plus 1 here. There you go. That's the decomposition. We've written this rational function like this. Pretty cool. Okay, in the next video, we'll do the remaining problems, which will be a little bit harder.